This lesson is focusing on prime and composite numbers. To understand this lesson, you must first understand the meaning of a factor. A factor is a whole number that divides exactly into another whole number, with no remainder. For example, the number 4 is a factor of 8, because 4 divides into 8 twice. Factors can be written as factor pairs. These are pairs of numbers that multiply to equal a certain number. So for example, if we have a look at the factor pairs of 14. The factor pairs of 14 would be 1 and 14, because 1 times 14 is 14, as well as 2 and 7. So the factors of 14 are 1, 14, 2 and 7. Now we can move on to prime and composite numbers. A prime number is a counting number that has exactly 2 factors, itself and 1. So for example, this includes 2, 3, 5, 7, and any other prime number that only has 2 factors. So for example, 2 is 1 times 2, 3 is 1 times 3, and so on. A composite number is one which has more than 2 factors. So for example, this includes 4, 6, 8, 9, and so on. That's because, for example, 4 is 1 times 4 and 2 times 2. 6 is 1 times 6 and 3 times 2, and so on. So let's move on to composite numbers and factor trees. Every composite number can be written as the product of powers of prime numbers. For example, here we have 12. We can write this as 2 times 2 times 3. Because 2 times 2 is 4 times 3 is 12, but these are all prime numbers. This then can be written in index notation as 2 squared times 3. A factor tree shows the prime factors of a composite number. Each branch shows a factor of all the numbers above it. The last numbers in a factor tree are all prime numbers. So let's have a look at an example. Here we have find the prime factors of 50 using a factor tree. So our first step is to write our number at the top and then come off with 2 branches. So our first step is find a factor pair of the given number and begin the factor tree. So what are some factors of 50? I've thought of 5 and 10. So if the branch is prime, no other factors can be found. For example, 5. So this branch is finished. If a branch is composite, find factors of that number. So here we have 10. So this branch is going to continue. So we need to think of a factor pair of the given number 10, and I have thought of 5 and 2. So these 2 numbers are both prime numbers. So now I can stop. So writing out our prime factors, we get 5 times 5 times 2, which is going to give us 50. Writing this in index notation, we get 5 to the power of 2 times 2 is equal to 50. So let's do one more example. Find the prime factors of 72 using a factor tree. So we start off by writing our number at the top, so we have 72, and I'm going to do 2 of my branches. So thinking of a factor pair for 72, I have thought of 6 and 12. These are both composite numbers, so I'm going to have to continue my branch. So a factor pair for 6 is 3 and 2. Those both are prime numbers, so I can stop there. And a factor pair for 12 would be 3, and 4. 3 is a prime number, 4 is a composite number. So writing out my factor pair for 4 would be 2 and 2. So my prime factors will be 3 times 2 times 3 times 2 times 2. And writing this in index notation, let's group our like terms together. So we have 3 to the power of 1, 2 times 2 to the power of 1, 2, 3. Thank you for watching.